Bem-vindos to one more episode of the Type Theory for All podcast. This is your host, Pedro Abreu, and in this episode, me, Eric, and Nitin continues our conversation started in the last episode. This time, we move our attention to the cool projects happening in COC. In particular, we comment through the projects mentioned by Andrew Appel on his keynote, COC's Vibrant Ecosystem for Verification Engineering, that took place in CPP 2022, which is a conference co-located with POPL. So without further ado, let's get into it! So, because Andrew Appel actually had a talk about a bunch of cool stuff happening in COC, that I actually I would like to talk about this stuff with you guys. I don't know, maybe we can come up with some interesting discussion and see why does Andrew Appel thinks COC is such a vibrant ecosystem for verification engineering. What do you guys think?
I'll say I see one of the tools listed on this is Iris, which
Yes.
I guess there were a lot of POPL talks which used Iris as sort of like a building ground for extending like different separation logics in different directions, like concurrent separation logics and stuff like this.
So let's take a step back. So Iris implements separation logic, a separation logic framework, if I understand correctly, for COC, right? Now, my question for taking a step back is, why is separation logic interesting?
Oh, I mean, I think I don't know if this is correct, but I thought like the idea of Iris or the development came to like try to have some tool to mechanize proofs about like proper memory usage in the style of Rust.
Yes.
And these
Yes.
things.
Yeah. So the main idea of separation logic, if I understand correctly, it is this notion of ownership, right? Like you can only use your resources once, or you have to take ownership of that resource, which is kind of the main idea behind the type system of Rust. And then they built Rust Belt on top of Iris, if I remember correctly, because of that, right?
Okay, gotcha.
If I understand correctly, I think.
I think there were two separate things said there, though, because using your resource once is not the same thing as having ownership over your resource. I think they're like dual concepts.
Can't you implement one in terms of the other? Can you implement one in terms of the other, though?
I'm inclined to say I don't think so. One of them is linear types and the other one is ownership types.
Yeah, that's really out of my knowledge. Yeah. But okay, yeah, that's good. A good thing to keep in mind. Thanks for bringing that up. So another project that he lists is, well, of course he would list it because he's the father, I believe, is VST, Verification Software Toolchain. You guys know what that's about? It's a really cool project, honestly.
Actually, no, I've not heard of this one so much.
Right. So the Verification Software Toolchain is a framework that translates. It's very similar to that thing that you were saying, that they translate C code through Isabelle.
Autocore is.
Yeah, Autocore.
For yeah.
But this one is for COC.
Oh, interesting. Gotcha.
So
Gotcha.
They get a subset of C, which they call C Lite. I don't remember on the top of my head what they leave out of C, but it seems to me that it's almost everything. It's in the C Lite. Mm-hmm. And then they not only translate it to COC, but also they provide a really nice framework in a separation logic, I think Hoare separation logic style for reasoning about your C code. And then they provide a bunch of automation tactics to automate things for you.
That's nice. I don't believe that Autocore is. I think it just listens to a regular Hoare logic. I don't think there's a separation logic component to that.
Yeah,
which would be quite nice.
yeah, exactly. So it's I don't know if that's the right name, separation Hoare logic, what I want to say is that there is a separation logic, and you use that in your in a horror style, right? In the sense of preconditions and postconditions, because that's how you reason about imperative code. To be honest, I think that's really ugly, but it's how you reason about imperative code, and imperative code is ugly. So that's me. That's my hot take
Yeah.
for the episode.
Yeah, there's one in autocores where you just apply the weakest precondition tactic and it blows away all the triples, and all you're left with is a couple proof obligations that look like normal Cox like goals.
That must be
I don't
really
know if there's
neat in Isabel though, because everything is so automated, right?
yeah. And basically all you lift it in autocores. Maybe you might have to adjust some like precondition, postcondition. Then you just blow it all away with weakest precondition. Then you're left with the meat of what you need to prove.
Mm-hmm. So he also mentioned CL4, but CL4 is not cock, is it? I'm confused now.
I don't know. I don't know if they've like ported some of that too.
Maybe he was, like giving a broader framework, like talking about in a broader sense, not only cock in this part here, because I didn't watch the talk. So anyways, he also talks about CertiCause, which is, I think, is Stanford project where they're verifying a really big chunks of an OS. So Certic COS OS, something along those lines. Concert.
Not too familiar with that one. Yeah, or with the Certicos one.
And then, yeah, of course, you have to talk about Concert when we're talking about formalization, of course. So for those who are not familiar, what Concert's about is, do you guys, does someone wanna take this one?
Go for it.
It's a fully verified C compiler,
Yes.
essentially.
Yes. What's so exciting about it?
So yeah, I'm the wrong person to talk about this. I'm not. So first of all, you know that GCC, Clang, they have several bugs within them.
Yeah.
So you add formal verification to the mix, you can exclude at least certain classes of bugs. That said, I don't know how they've done it with ComCert, because as far as I understand, a lot of like the semantics of C is actually undefined, and they actually leverage that for optimizations in these compilers. So I don't know how much success ComCert has with that undefined behavior, but so the question is what they're actually proving.
There's some research. So the only part that they left out, that they didn't prove some stronger properties of the compiler, is the parser, if I remember correctly. But there's some research of, like how many bugs they could find in C compilers, and ComCert was shown to have the least amount of bugs, and that was amazing. Yeah, I think it's important to mention that ComCert, I think, was one of the first really big projects in Coq in the field of compilers, So I don't know. So the guy who did this, what's his name? Xavier Leroy. Oh my god, I just butchered another name. How many names am I gonna butcher in one episode? So I'm gonna talk. Let's use no, yeah. So Xavier Leroy, he's insane, man. How do you how do you wake up one morning and you're like, you know what? I'm gonna verify a C compiler using Coq. Who does that?
Oh, I gotta admit, it's a dream.
Right? And he did it. That's the worst part. He did it.
He did it.
Yeah.
Oh man, he's a hero for us. Thanks, Lewa.
I'm really curious, like how ComCert, like programs compiled with ComCert compare to programs compiled with GCC and Clang in terms of performance.
Yeah. Maybe that research that I was talking about, I'll have to link that in the description as well. Find this research that I was talking about. Maybe it doesn't even exist. I'm making up things on the fly here, and, and I'm full of shit. I don't know.
To go through at the end, though.
But yes, I will provide the papers backing me up, or at least I'm gonna say, hey, I was full of shit in that part.
Nice.
So another project that he mentions is Bedrock's C++ toolchain. You guys know what Bedrock is?
No, I've heard of
No.
Bedrock Systems as a company, but I don't really
Yeah.
know what they do.
Yeah. So Bedrock, there's a collaborator of Ben that is his in our Slack. I don't know how
Is
much
it
they
Greg?
collaborate nowadays. Yes. So Greg Malaka, he was I don't know if he has any share in this company, but he's definitely the lead proof engineering behind Bedrock. And what they're doing, if I remember correctly, now I can go really wrong. They're formalizing a hypervisor.
Oh.
So I'm not an OS person. I'm not really sure
Yeah.
what a if any of you want to explain what a hypervisor is, please take this.
Right. So a hypervisor, well, I'm not an expert either, but a hypervisor is just essentially a system to help run operating systems while logged into your current system. Like it's like VirtualBox, VMware. Those are hypervisors.
What's the difference?
Between,
Yeah,
sorry, the difference
Between
between
what?
a
Yeah,
hypervisor and a box that you said.
Virtual Box?
VirtualBox
Yes,
and
VirtualBox.
VirtualBox and VMware are examples of hypervisors.
Ah,
Gotcha,
Hyper-V by
okay.
Microsoft. Yeah.
okay.
Is
So
this sort of to address like security issues with things like
Ah.
Docker or similar systems?
So
I think
for Bedrock, what they're doing, they're actually doing that for what's the word? Autonomous cars. Yeah, pretty cool, exciting stuff.
hypervisors for autonomous cars. I
No,
don't even know what that
I
would
can
mean.
I can be really full of shit now. But yes. Well, I mean, the autonomous car, they must have an operating system, right? So this hypervisor piece is kind of like an important piece of the operating system to make sure that things are gonna behave properly, right? Something along those lines.
I'm beginning to wonder if hypervisor is being used in a different context here. Like it might be the same thing, but
I'm gonna
I
stop
don't
here because I
understand.
think
Yeah.
I already said way too many shit about. um, so Andrew Appel also mentions CFML, something called which is characteristic formula, a program logic for
Oh, I
OCaml.
thought this was going to be like verification of ML systems, which
Yeah.
I don't really I don't know how people approach this, but at least at POPL this year, I saw people talking about trying to use abstract interpretation to verify that calculations are within like use like box things with intervals or something, and then like intervals in higher dimensional spaces or like you're boxing functions to certain regions or something like this. I guess I mean if ML largely boils down to functions, massive functions, then I guess that kind of makes sense as a verification goal. But there was a lot of talk about that in POPL. It all goes over my head, but it's interesting to see that on the table, the
Yeah, it would be
verification
fun to
table.
have a talk with an ML expert and try to figure out what the place for
Yeah.
dependent types in machine learning are.
Well, I mean, Talia is like on Twitter, she's like right
Yep.
in that space, interacting with both of those communities. Yeah,
Mhm.
it's really interesting to
it's
see.
exciting, yeah.
Well, the next project that he mentions is Refine C. This one was definitely a new one for me. I never heard about this one, but apparently it's refinement types and separation logic implemented with Iris. So
Wait, so for the refinement types part, is this like refinement types in the program that you're verifying, or you get refinement, or do you have some notion of like refinements that you're being able to use when you're verifying something? Like, as in to say, do you have, are you verifying a language with refinement types and separation logic, or do you have refinement types available for you in verification?
that's a really good question that I don't know.
Yeah, like I'm not
Yeah,
sure.
like another open question is I'm curious how this differs from Ranjit Jala's work on liquid effects in C-like languages. That would also
Interesting.
be
Isn't
yeah.
liquid types kind of like
That's the Haskell
refinement?
notion of refinement types, I believe.
Right, but he also has something on liquid effects for
Oh,
languages
Oh,
which are closer to imperative languages. And I'm curious what the distinction between this and that would be.
yeah. I don't. I don't know. Like also Scala has some like Scala stainless, I believe is what it's called. But that seems to follow more of like the liquid Haskell doctrine. I don't know if that has anything from this liquid effects notion. I don't. Do you know who publishes in that space? I've not heard of that before.
I'm not super sure. No.
Liquid effects was the
Yeah, liquid effects. So it was liquid effects.
maybe
Run.
Nikki Vazo has some stuff there.
well. Google tells
Oh,
me
okay.
it's lotion, so I don't think I got the right.
Deterministic parallelism via liquid effects. Oh, okay. I think the name of the paper has answered my question already. Deterministic parallelism via liquid effects.
Okay.
Okay.
Huh. Wow. Damn. Okay, moving on. And then, so all of this was tools for verifying imperative programs. That was the last one. And then the next umbrella he puts here is tools for verifying software in general. And he mentions this one tool being developed in MIT, I believe, called Koika.
Koika,
Man,
yes.
is this actually?
Effects. Koika is the effect language, right?
Yes, it's MIT. It's a core language for rule-based hardware design.
Oh, never mind.
So
What was I
yes,
confusing with?
yeah, well, they are building a design language inspired by BlueStack system Verilog. And I don't know, I think it feels to me that this is kind of a used to be Kami at some point. I don't know. I know Kami was very similar to this idea. Maybe they're different projects altogether, but
I'm curious to know what this is because what we're one of our hardware verification things we're using something called Rewire, which is you're able to sort of specify your RTL language in Haskell and it'll synthesize to VHDL or something like this. And
wow,
then
wire,
Rewire
rewire.
uses something called a reactive resumption monad to sort of model um, circuit effects.
That sounds really interesting. I wonder if you do that. Wow. I wonder if you do that, you come up with all your language in that, and then I don't know, you use some tool like Haskell, like to to put it in Coq and reason about your code,
You could do something like that.
or or if it would be better to, hmm, I don't know. Interesting
Yeah,
thoughts.
I mean it's better than RTL is disgusting to write in or disgusting to read too.
Oh,
Yeah.
it is. Oh my god. I can tell, yeah, when I was in Sci 5, I was implementing the floating point unit using this language. Like, so I said Koika seems similar to Kami because I use Kami for this implementation. So basically what I was doing is programming hardware in Coq. So I was doing two very hard things in one.
Yeah,
And oh my god, it was hard. It was
that
hard.
sounds painful.
Yeah.
Sounds
Anyways,
interesting, though.
it was very interesting, but don't put floating points in front of me. Anyways, so then the next umbrella he puts here is about functional programming. And so again, we're talking about verification in Coq in general. So what are the tools available for reasoning about functional programming in Coq? The first one he puts is the Coq standard library, saying Coq std++. I don't know how standard it is really. I don't think this is maintained by the Coq team. Uh, is it? Maybe it is.
I see MPI. No.
Created list. Maybe it is. I'm not sure. I don't know. Oh,
I think
yes,
it's.
I'm seeing
I don't know if
MPI too.
it's.
Yeah. You're
Yeah,
right.
Max Planck Institute software or something.
But that's a really cool thing though, because I don't know, like it feels like Coq is becoming a much more community based and not so centralized just for the developers, because their core developers is very limited. And us, the community, is starting to take charge, of developing stuff and maintaining cool stuff. There's actually there is another really interesting project that call anyways they're trying to have the curated list of important bigger projects in Coq. So in order to get maintainers to actually keep these projects alive even though Coq is still evolving, so every interaction, like every new release of Coq, there is someone that's going to go through and make sure that things is still working and not breaking and come up with a new release of this library. And that's an amazing stuff going on in our community. So if you I have to look at the name of this. It's a GitHub project where they list everything and the people who's actually in charge of maintaining the code. So if you are a Coq user and you want to volunteer yourself, that would be amazing, an amazing thing to do.
I on one actually real quick note on the community is I think it's like in a week from now that there's a new proof assistance stack exchange is launching in beta
Oh
on
yeah,
like
that
February 8th.
$100.
Yeah.
Oh, that's
So
lovely.
it should be bring together folks from all the various theorem improvement communities to yell about why their proof assistant is dumb and also how to do things.
So, but what's the idea of this to improver? Oh, of this new stack exchange?
I
Because
think it's for both implementers in the community and folks trying to learn these things. Like, I mean, if you're a mathematician who wants to go from like lean to maybe something like Coq or whatever, and there's not, you kind of want to have someone like either with you to tell you the difference or some things, or like give help you locate resources, stuff like that.
it's a place for us to hang out, in a sense of
Yeah,
putting all these people with different backgrounds together, but with the same
yeah.
goal, which is reasoning about theorem. Is it theorem improvers? What's the name of
Yeah,
this stack?
I think it's like theorem prover stack exchange. I think it's also to solve the problem where you have a whole bunch of things like people asking about formalized proof in like the mathematics stack exchange or theoretic computer science stack exchange, or you have people asking like more programming related Coq problems in like software exchange. It's just finding a place to aggregate all of these into one spot where it actually fits.
Yeah, that one is really cool.
Yeah, that would be awesome.
Yeah, I think should be like beta in about I think it's February 8th. Yep.
Nice. 8th, right? The 8th. So next week, next Monday.
Yeah.
We're in
Here,
February.
I'll post it
1st,
in our
right?
little chat here, and then we can. There's a
Oh
link
yeah,
too.
gotcha. Yes, I have to put this in the notes of the podcast so that I remember to put
Area
it in
51 stack exchange.
the thing.
Yeah, there's staging zone. So you had to
Yeah.
propose and meet a certain threshold so that the people would be like, okay, we'll make you this community, or like on our site here.
Cute.
Yeah,
Yep.
it's funny. So coming back to the projects that we can use in Coq in order to formally verify functional programming stuff, we also have the foundational cryptography framework. I have no idea what that is. This next one has a funny name. It's called FOCQ. Fuck you. It's
Yeah.
FOCQ. FOCQ.
Yeah.
And they're formalization of floating point stuff used by ComServe.
Hey, your favorite.
Well, as long as it's not hardware. But
Yeah.
no, yeah, it's no. Keep it away from me.
Yeah.
Then we have cockreels, we have intervals. Oh, this interval is actually interesting. It's a project for reasoning about bounds for approximation errors.
Yeah, I wonder. Yeah, if
It's kind of
bounds for
like when you're dealing
approximation errors.
with floating points, then there are some approximation errors going on. So it's kind of like to
Gotcha.
fill the gap between working with your formalization with reals, with this how your actually numbers work, and your implementations, which is actually floating points, right? So kind of trying to fill that gap, I believe.
Yep.
Which is important. It's really important. Mathematical components. Did you guys ever work with MathComp?
No, but I'm wondering if I've been watching the London Lean seminar because I'm curious as to what mathematicians want to implement in MathLib and where their pain points are. I'm wondering if I don't know if Coq has an equivalent to sort of MathLib, like what Lean is building.
Well,
it's basically like a large hierarchy of algebraic structures.
I think that's MathComp.
Okay.
Yeah. But the key thing about MathComp is that it not only formalizes a bunch of amazing mathematical stuff in Coq, it also kind of provides a bunch of tactics in order for you to better reason about all this mathematical stuff.
Does it involve POPL? Reed was mentioning that he was working on there are existing like mathematical solvers like Sage or Magma or something like this, but these are sort of for solving specific problems, not necessarily proving theorems. And I don't know how much of that sort of tooling has entered the interactive theorem proving sort of community, whether as like an augmented way to, I don't know, solve certain like word problems in, I don't know, like it's really good at reasoning about algebraic structures, like solving problems. Like it'd be like adding an automated theorem prover, I guess, almost to Coq or something like that. I don't know if folks have looked in that research.
What's the name of that again?
I don't really have a good reference for you. I know Reed was talking about it at POPL, and
okay.
It was basically just saying, hey, what if we took Sage from something that's well used in the mathematics community, something they're comfortable with, and tried to add this to Coq in some way that makes sense. Let me I'll pull this up real quick.
Open source mathematical software.
Yeah, it just says Sage can perform various computations related to basic algebra and calculus. For example, finding solutions to equations, differentiation, integration, Laplace transforms, blah, 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 blah. But apparently, like, for mathematicians who are using tools, they're more likely to be using these basic algebra systems than Coq.
Oh, do they? Yeah. How do you prove things in that?
I don't think it's not necessarily for proving per se. I think it's mostly, well, it's not like an interactive theorem prover. It's more of a solver. Yeah.
Right. So more of an automated theorem prover, we can say.
Sort of.
Is it
yeah.
even a solver? It seems to be. It says that it builds upon existing packages like NumPy, SciPy. So it seems to be more mathematical computations.
Just the computation part.
Maybe there was another one too. What's the Sage first?
Yeah, I'm looking at something called Sage Math.
Looking for. Oh, I see. Sage Math. Oh yeah, sagemath.org. Yes, this. There was another one. It's not called Magma. Software. Or no, yes, Magma, computational algebra system. This is probably more of what I was thinking about. Okay, it provides mathematically rigorous environments for defining and working with structures such as rings, group fields, modules, algebra, schemes, curves, graphs, blah, 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 blah. So that's probably more of what I'm thinking of. Magma also supports a number of database designs to aid computational research. Yep, and those of mathematics in areas of mathematics which are algebraic in nature.
Is that one developed in the University of Sydney by any chance?
It says maths.uni use maybe
Yes,
usid.edu.au.
university.
Yeah, that looks like
Yes,
yeah,
University of
Yeah.
Sydney. I was
yeah.
there. I had the chance to use that for our cryptography class, and
Oh,
it's
really?
so it's so cool. It's so
So okay,
cool.
if you've actually used it then, so what
Yes,
is it?
yes.
What is it like versus like an interactive stamp prover?
It's more
Like,
a computation thing,
okay,
like because what is well, I used it for in the realm of cryptography. So, for example, for applying the Caesar cipher to a text, like, and to decipher. So, for example, one really cool thing that I remember was I provided a text, a plain text, well, an encrypted test, and then it would give me the percentages of occurrences of each letter, for example, so that I could fit that back into what's the most likely word, like letter, because there's a letter that happens the most in English, right? And then interactively, by using the tool and the software they actually provide, they already implement all of these interesting functions that you want to use for cryptography, right? For deciphering and to decipher. So it makes our life so much easier. But yeah, I use it in the context of encryptation. So it's not really doing proofs. It's actually just as Nitin said, I'm doing the computation, but it's really providing
yeah,
all the support that I need to do that computation, right?
they have a lot of
Yeah.
things with big scary words like sheaf homomorphisms.
Oof. Oof. No. Yeah.
Fun like this, yeah.
Um.
Or they've got algebraic geometry in here, topology. They've
You
got
know. I.
simplicial homology, if you will.
Ooh. Damn. I think if we stop where we are, with the three of us, stop where we are and learn a lot about cryptography, I think we could do a lot of money. We could make so much
Yeah.
money, like, just proving that all this
I mean,
stuff actually
I
works and is correct.
yeah. I mean, isn't that? I mean, you could at any point go to one of those crypto formalization shops, right, and verify their language. I mean, I guess that's more of
True.
formalizing their language
True.
rather than the actual cryptography. But
Cryptography.
yeah.
I
Well,
mean, that was the
it's
core behind developing FStar, right? Formalizing cryptographic protocols.
Oh, really?
It was one of the core motivations, yes.
Gotcha. What did Epstar have any like overlap with Galois? Like, were there any like crypto converts that or crypto
I'm not
cryptol?
really sure.
Gotcha. Gotcha.
good question. I don't remember seeing any of that, because I remember when I was there, I hovered over trying to see all the projects they had and talk to
Yeah.
people, but I don't remember anything related to F star. I remember I saw
Oh,
even
I
even
guess.
lean at some point, but not F star.
Yeah.
I
I
think
guess
FStar
Fstar
keeps
would give
rapidly
them.
changing, so it's kind of hard to adopt outside
Yeah.
MSR.
I guess crypto will be more about I want to verify like my spec, and then Fstar would be I want to
Yes,
actually verify my code that implements this spec.
They also
Yeah.
did construct like a domain-specific language within FStar, particularly for crypto, like implementing cryptographic protocols. I believe I forget the name. It had FStar. Yeah, I don't remember, but I'll probably send it to you after the talk, and like you can add it to the references, Pedro.
oh yeah, for
Yeah.
sure, don't worry. No, but oh my god, I blanked now.
Yeah. I want to learn. I want to spend some time hacking around with Fstar.
Yeah.
There's some
you
this.
know
Yeah. Go ahead.
Another thing that is really on my learn list forever now is learning some lean as well. Like, I
Same.
never touched any lean code, and I don't know, there's so much happening that I just feel like missing out so much.
Yeah. I the thing that is weird about like the thing that's weird about like Lean and its users from what I've seen is this goes back to sort of the POPL workshop where it was like Kevin Buzzard and Nicholas from um, sorry, the cock maintainer. I forget his last name. Begins with ends with a T. Inria. Yeah. Anyway, sorry. It's like the lean community's willingness to just like give up on subject reduction.
Oh
They
yeah,
just
yeah,
like
yeah. You watched
yeah,
that discussion. What happened there? Give us the
yeah.
deets.
Well, Kevin's idea, like, because he just basically talks with a whole bunch of mathematicians. He's like, okay, when I'm doing my mathematics, I want simple rewrites and quotients that work, and that's all. That's what I need. That's why I feel like I'm missing in like a normal proof assistant, and so they're perfectly fine with the way like Lean implements quotients, but folks, type theorists in the audience were like, well, the way you implement quotients doesn't it like breaks subject reduction or stuff like this.
Quick interjection here. What's
Yeah,
subject reduction?
it's that you when you're reducing the term, it stays the same type.
Oh, preservation. Okay.
Preservation. Yeah, basically. Yep. But yeah, or like it's one of these like foundational properties you'd expect to have, but quotients break it.
Huh.
Yes,
Wait,
it's the same as type
if
preservation.
quotients break it, does that mean
Their implementation? I don't know
It's
exactly in what
unsound.
details.
That means it's unsound. The type system is unsound.
Yeah. So if you look
that's a
at,
bold move?
you can find like GitHub issues with discussions about this, or I guess a
Oh
couple
my
blogs
god,
on
that
it now.
discussion is
Those are the
so
best.
heated. It's so funny
Yeah.
to read because at some point one of the maintainers, developers of Clock is just so inflamed. Like
Yeah.
he gets really snarky at some point.
Yep. Yeah.
It's funny.
Yeah. I
Anyways,
don't know. So go ahead.
oh yeah, it's very interesting all of this discussion because was Leonardo there in this?
No, he wasn't. There was
So for the listener
no.
who is asking himself who's Leonardo, so it's the creator of Lean is Leonardo Gimoda. Leonardo Gimoda. Well, anyway, so I was actually watching a podcast. He went to 2 podcasts, and one of them I have the luck to be in Portuguese. So like I'm like, oh my god, I wanna share this one podcast with everyone, but nobody speaks Portuguese. So, but the second one was for Joey Dodd's podcast, Building Better
Oh yeah.
Software, and it was a really cool podcast because he is really passionate about the project and he's talking about the difficulties and kind of the vision behind Lean. And that's exactly the point. Like the vision behind Lean is to be a practical tool for mathematicians. And I think that's a very different vision for Coq, where it seems to me that the original vision, I don't know how it is today, but I think it's, in a way, it's still that. But the original vision for Coq is to implement a beautiful type system, right? Like to really look at dependent types and implement that. And how can we build a nice directive theorem improver from first principles? So it's not only a usable theorem improver, but a correct by constructor, like first principles and everything is well done. And
Is it really
Agda kind of takes that to the next level, if I understand correctly, where they even learn from the mistakes of Coq and even implement things in an even more foundational and cleaner way, in a sense, because it was newer and they could, like learn
I
from
don't know if I
mistakes and whatnot.
agree with you on this. I might be missing some critical information here because I don't know a lot about Lean in particular.
Okay.
Like, for example, I did not know about like the uh, lack of subject reduction, but to my understanding, Lean and Cox type system is actually based on the same foundations.
Yeah,
And Agda
Coq
is
of
actually just
construction.
like, and Agda, I'm not sure if you would call it Cox simplified exactly. It
Oh, I
completely
didn't say Coq. I
foregoes.
didn't say simplified. I said that
You're
it
right.
learned
You're
from
right.
its
I guess I heard. I
Yeah.
mean, I was listening to what you said, but I took the wrong message from it.
Okay.
And like, yeah, it sticks with predicativity and does not go into the realm of impredicativity at all, as far as I've seen so far. I think they do have now, but I don't recall whether that's actually. I don't think that's actual in predicativity.
Yeah. But that's kind of beyond the point, because like even Coquin himself, like the father of Coq, worked in Agda. He works in Agda nowadays. So like so Agda and Coq is the same thing in a way. They definitely do have the same foundation. So here's the thing that I wanna to wrap up my what I was saying about Leonardo, is that he is not a type theorist to begin with, and he always make this very clear that he was kind of like learning as he goes. So for those who doesn't know as well, he's also the father of Z3. Z3 is the most widely used SMT solver, and he's the person behind that. And I think he got bored at some point, like, okay, what's the next very hard problem I can work on? And like, oh yeah, let's do an interactive improver. And he's like, okay, how am I gonna do it? Oh, I don't know. Shouldn't be that hard, right? So in this podcast episode, he's like, turns out it's really hard.
Uh-huh.
And he was kind of learning as he goes as well. That's why he started from scratch for Lean 3, and that's why he's kind of starting from scratch for Lean 4 as well.
I'm curious how you just kind of dive into that. I mean, I feel like most of us in PL research are like, all right, well, I'm gonna start with our simple type systems and build up, or like,
Yeah.
encounter dependent types via like
Yeah.
working on a
He
theorem
wanted
prover or
to
something
do
like
apparently
this.
he wanted to do a very usable, good theorem prover that would be more usable than say Coq, but he had no idea how hard it was gonna be. So I don't know, he and his team is just so extremely smart that he just kept learning and learning from the mistakes. And I don't know, I think in a way how Lean is doing the stuff is kind of the future, because I don't know, from all I see and I read, things are very well done. But I don't
I
I'm
love.
not I'm not really sure how this lack of, for example, breaking subject rejection, like how much does this actually impact the language? Because
I mean, the
you know
mathematicians would largely not
care.
care in a way.
So my question
Like
is
if you,
why we as programming language people would care? Why does it care for us? Why does it matter
because
for
I
us?
think we're looking at them as like studying them as like a very advanced rewrite systems. We want to have like a very sound, nice meta theory and know exactly what's going on.
I think
Versus
the
a
main
mathematician who's
point
just like, give me something I can code my definitions in.
I think the main point really is that if you leave that away, then you will either have undefined behavior, or you're actually going to have a bug somewhere. And if you have a bug somewhere, what this means in a proof is that your proof compiles, but it's wrong, right? What does that mean for a flying plane
Yeah.
with formally verified software?
Yeah.
But what does that mean for a math proof? Those are two very different things. So I think the main point that I want to make is that for formalizing software, maybe we should care about the formal properties. But for formalizing mathematics, maybe it's okay to be a little more lenient about that.
That would be an interesting. I don't know. I mean, it's almost like this is kind of experimentation in that. I don't know. I mean, the fact that they're willing to consider making those design decisions just so it's better supports that community is already kind of interesting. I don't know. Instead of having, oh, here we've created this tool, we've researched this type theory, we've made it practical. Uh, Now these people have built these fun things in it, but you're not really like, I don't know, catering necessarily towards your crowd. I mean, to some degree you are trying to make things nicer to use. I
Those
don't
are
know.
very good points. Yes, I agree.
You could also view it as just going the other way around. Like for example, they like pulling back to Scala once again.
Yeah,
They
Of
yeah.
developed
course.
the compiler, and then eventually they developed the meta theory. Like I said, it took almost a decade for them to come up with dependent object types as the type theoretical foundation. So
Yeah.
develop the language for the people who you want to use it, and then slowly start showing how to build things the right way, and let your discoveries of the meta theory inform how to patch your compiler.
until you get C, right? No, I'm just kidding.
I don't know.
Yeah.
I'm not sure if I agree with that entirely, because it's much easier to build something from first principles, from the ground up, than to have, what if the whole foundation of your compiler is just unsound, just wrong. So in order to make a change in this foundation, you literally have to change the whole language. Think of it this way. Maybe you come up with the discovery later on in your meta theory that one of your constructors is badly, like, doesn't behave as you expected because of this type thing. And then in order for you to go back, you have to slightly change the syntax of your language, like the actual tree of your language. So if you're changing the tree of a compiler, you're literally changing the whole compiler, and that's a huge pain. So, well,
Changing the
sure, you could do it like
syntaxes.
that, but it would be so much rework. It would be so much rework.
Well, there actually have been some changes which led to a lot of rework even in the Scala compiler. For instance, at some point of time, it was actually possible to encode the SKI combinators within Scala's type language alone, which, as you can see, would
Nice.
be a big problem. And
Why?
nowadays that's not
I
allowed
don't
anymore.
follow. What is that?
Uh,
That's
the SKI combinators, they're basically just three combinators which are they're equivalent to
untyped
the
lambda
untyped lambda
calculus, right?
calculus. Yeah. Essentially, you could write a small DSL within the type language for the untyped lambda calculus,
So that
which
means
Yeah.
you can write omega, which is like lambda x
yes,
x x.
yes,
Okay, okay.
this was a bug which was discovered in Scala 2, and I believe they patched it in Scala 3, or maybe in one of the later versions of Scala 2. So yes, you are right. A lot of major compiler rewrites had to happen.
So just
Yeah.
for the listener to follow it a little better, maybe. So if you can write down simple type lambda calculus, it means that you can have an unbounded recursion, right? So lambda x x x, it means you're applying a function to itself, and that never terminates. So you're building on non-termination, and that really breaks your type system. So what you're saying is that they found a bug where they could come up with non-termination, but non-termination is fine for in the type system. So
In the
non-termination in the type
type
system.
Yeah. Be careful where you put that
Right.
non-termination.
Right. No, yeah. Your type system must be terminating. Your type checking must terminate. Yes. Very important. How are you going to compile if it doesn't terminate? Yes. Okay.
Speaking of, I guess, like type theories and constructing proof assistants out of them, there was a paper in this POPL about observational type theory, and I think
yes,
it might have come up in Ben's research group
Oh yeah.
for one of the paper readings. I don't think I've seen or played with a nice implementation of an observational type theory to kind of get a hands-on feel for what it's like to work in it. Are either you aware of an implementation?
I think Epigram uses observational type theory, if I'm not
Oh,
mistaken.
really?
I
I've
might
never
be
opened
wrong.
up Epigram.
Yeah,
that would
Connor
make sense because it's
McBride.
McBride. Yeah.
Yeah. Like, he himself laments on his webpage about how Epigram hasn't taken off. It's McBride's writing is amazing. I love him.
Oh, yeah. I see a lot of that, especially when this observational type theory came out. This new paper, and he's like, "Yep, see this stuff." My stuff that gets rejected years ago is now relevant.
I think Thorsten Altenkirch also worked on Epigram, because I definitely remember asking him on his episode, like, what about Epigram? What's going on? He's like, yeah, it's kind of dead, I think.
Yeah.
Oh man. Oh.
I think it was I think Connor gave a talk at the Topos Institute, and he was lamenting about how Epigram is in its grave, blah 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 blah.
So I'm curious, since you brought it up, I never really got down to digesting the benefits of observational type theory. I understand it's supposed to be some kind of middle ground between extensional and intentional type theory, but like, where exactly does that middle ground lie? Do you know?
I don't off the top of my head. It's something I read. I read one of the earlier papers. I think it might have been by Connor himself instead of people who followed his work as derivatives. This
Right.
is a while ago. Um, I, I really don't know. It's something that it's like near the top of my list, my queue. That's
Right.
why I like to play with like implementations first to kind of get a feel for them, and then go to the Greek.
Makes sense.
Yeah.
Oh,
Well, I think I think we covered everything that I had to cover and way much more, which is awesome. I think we had a really nice conversation. We definitely mentioned a bunch of cool stuff. Hey, Eric, I have a cool update for you that I think you're gonna enjoy. Is one thing that we didn't have the chance to go through, but I think it's not super worth it for this episode anymore because I think we already talked about some stuff that is much more interesting. But I was also looking at some cool projects on the Agda side,
Oh yeah.
and Jasper Cox is working on a tactic library for Agda.
Oh,
That's
finally.
exciting,
yes.
huh?
Yes.
Yeah, because
You.
currently all you have is query agzi and pray to God. Like, I mean, you
Hmm.
can you can be like, hey, I'll let you, unfold definitions, or I'll give you a few definitions and unleash it, but it's bad. I mean, Agda to me is just kind of like, I don't know. It's like a blackboard where it's nice and pretty, and I can put my definitions, and everything's nice and concise. Uh, but I really don't use it for
Straightforward.
proving.
Yeah.
I was curious about that though. So, to my understanding, they're using some kind of meta programming monad. Is it similar to MTAC and Coq?
I actually this came up in Wits. I think it's like this elaboration. Uh, this is something I can actually just post the link to afterwards. I don't know off the top of my head. But I think I got a slight demonstration of that where he's like quoting the syntax and returning Agda terms for proof search. Yeah.
That's cool. It's pretty cool. You know, this quotation stuff is something that really goes over my head because, for example, like if you're using a Lisp family language, then it's kind of like it plays a major role, right, on how your programs and quotation. What's the idea? Like, why would you like to quote things? Like, how does it help you?
I'm sorry. I'm trying to pull up the. I saved the Wits tutorial, so I actually have it. Here it is. Reflection monad syntax. Yeah. Sorry to interrupt that, but yeah, here this is what he pulled up in the workshop as an example.
Who did
Um,
this?
Jesper Cox.
Oh, really?
This was the workshop he did. He was just talking
Macro.
about the system and his problems he was having with it.
Is macro
Mm.
like a new keyword, or did that always exist and I just didn't know about it?
I mean, I have not used macro, so yeah.
Macro. Oh, I think I
Yeah, it's at
clicked on the
it's like
wrong link.
line 16 there.
I
But yeah,
think.
this is an example of yeah, because you have access to the type checker in this too.
Damn.
Yeah.
Some cool stuff. Well, we'll make sure to post that in the links on the
Yep.
description as well. Oh, I see. So, what's the idea of quasi quotation? Like, it gets for you. What's quasi quotation? I really have trouble getting my head around.
I'm not sure what he's referring to in that comment. Lack of quasi quoting of terms in both expressions and patterns.
I mean, I think the original motivation for quotation in Lisp-based systems was to design like programs to for artificial intelligence and such. And but yeah, I'm not super sure either. This is an open question for me as well. Like, in what contexts would you choose to use quotation over other techniques?
Okay, so I think that's homework for all of us.
Yep.
What? Well, I
Yeah.
There was
think.
one other thing that I wanted to actually bring up because, like,
Mm.
I think I
Yeah.
forgot to throw it on the list. Have you guys been following the work on the recent Idris work?
No.
Idris, no.
Yeah. Yep.
So,
Bloodwine is out though, right?
sorry, what's that?
So Idris had a major new release that was supposed to be called Bloodwine.
Oh, okay.
And no, I don't
No,
know.
I wasn't familiar with the name. I was more familiar with a particular facet of the type system called
Okay.
quantitative type theory, where they have
Oh,
finally
Quantitative.
learned how to like marry dependent types and resource calculi. Like it's quite beautiful, actually. I absolutely loved that paper. I think it was
This
Bob.
is. Oh, sorry.
I
Go ahead.
think I think it was Bob Atke who actually wrote the quantitative type theory paper. It was based on a previous system by Connor McBride, but there was a small bug within the paper,
Mm.
which was caught in this one, and he furthered the meta theory to something which I believe Idris is now using in its base
Wow,
type
that's
system.
fun.
Yeah,
Yeah, I
so
see one from Edwin Brady that's a little bit more recent in 2021, Idris 2, Quantitative Type Theory in Practice. And it says in this paper, we introduce Idris 2 and how quantitative type theory has influenced its design. Interesting. Yeah, give some examples and benefits of it in practice, including expressing which data is erased at runtime at the type level. Ooh, fun. Yeah.
mhm. It's very exciting because so I really like this paper because before this paper I would simply view contexts as partially ordered sets. But this paper
Yeah.
gave you the perspective that if you simply change that view to viewing them as vectors instead, you can track
Yeah.
resources, and that is a very elegant idea in my opinion.
wow.
Mhm.
Wait, but hang on. Can you say that again? So you see the what as a
So
vector?
all right, so contexts typically the way I was like
Oh, I
viewing
see.
them when I was
Okay.
trying to model them was sets containing like your variable and the type associated with it.
But they're
Mm-hmm.
also
Uh
ordered because of dependency, right?
yes, ordered because
Right.
of
Yeah.
dependent types.
That's a
And
Yeah.
telescope. Just to be more precise.
yes, a telescope. And quantitative type theory says let's also annotate all these variables with a quantity. And suddenly you have a view of these contexts as vectors. And this is an important view because some of the typing rules require you to add like two different contexts together to combine the resources and such.
Nice.
I guess it would get too technical if I went into the details, but it was a very pretty idea, and I really
Is
liked
it,
it.
wait, is it more than getting rid of, what is it, exchange or weakening, like a substructural logic thing? Like, like where you can't permute your context, or you can't permute entities in your context, and you can't duplicate them, or something like that? Is that essentially what's being enforced
Uh,
here? Is that the linearity part?
I'm not sure about the can't permute part. I wasn't
Yeah.
so, but
Or
certainly you
I
can't.
guess,
Yeah, weakening is not. I don't
yeah.
believe weakening is permitted in this system.
Okay. But I get,
And
okay.
I have a
oh, and
question.
also yeah.
This sounds similar to linear type system. How does it
Oh,
relate?
it's very similar to linear type systems. So linear type systems are systems where all the quantities are either one or many. You
Hmm.
can annotate things as linear. Quantitative type systems
Ah,
say they basically just extend the ring further. You
right.
have and you can I believe you can choose any ring for a quantitative type theory.
Damn.
Like if I'm not mistaken, I mean we'll put in the comments of your video whether or not I'm bullshitting on this, but I do believe that you can choose the ring. There was a proof assistant that was being developed at IISc in Bangalore. I don't know too much about it, but I've always wanted to dive into it because it sounded very interesting. It was this thing called Proving Grounds, developed by a certain Siddharth Gajila, I think. I might have butchered that name. Uh, it's very interesting. So it uses homotopy type theory in order to prove things. I believe there was also a component to it which was trying to do natural language processing on mathematics. which is
Wow.
absolutely fascinating. Unfortunately, at the time that at the time that I came across this, I was still an absolute noob when it comes to type theory and such. So but I do hope to like go back there and try to actually digest what he's done over there. It looked fascinating. Right?
Yeah, I found it. Oh, interesting. Yeah, I'm trying to get a better understand. Oh, they have some. I see a website and some tutorials. Proving ground.
Semi-automated theorem proving.
That sounds really cool. Cool
Yeah,
stuff. I
it
Hauling it.
uses.
I find it very exciting to see all these new projects coming along in this line, like tier improving, automated tier improving, or interactive tier improving. How this is slowly trying to get more mainstream. I think that's really nice and cool. Really nice and cool.
Yeah, it was interesting to hear from Kevin Buzzard saying, "Yeah, I'm trying to teach. We're trying to build up a repertoire of like undergraduate math libraries so that we can teach our undergrad math students using these tools."
Hmm. Yeah, that's it's so one of the things that Leo talks about a lot is how we got a point in mathematics that it can be really hard for someone to double check your proofs because they're so huge, and it's very hard for another person to know what you're doing, like to be in the actual same subfield, like specialize so much that he's gonna be able to follow every single detail of what you're doing, right? What if we have this beautiful world that does that automatically for you, and you can trust this beautiful world that your proof is actually correct and bug free, and you don't actually have to understand all the minor details because you know that the tool understood it under the hood and guarantees that things are being done properly. And there is also another very interesting argument, which is these proofs are huge, and many times they have many tedious similar cases, right? That it should be easy to discharge. One of the reasons why the four color theorem was made in Coq is because a lot of the proof was just proof search, just computation, like just brute force. And you can do that really well in theorem provers. That's what computers are for. Computers are really good at doing dumb stuff many times, many times. And turns out that some proofs are just like that. And what if we can tap into that? It's the best of all the possible worlds, and that's great. There is another very interesting project as well. Since we are talking about like other projects that is like how theorem proving is kind of trying to creep into mainstream. When I was looking into different Coq or Agda stuff going on, I found this language called kind.
Yes, formerly formality.
Well,
Oh,
it
wait.
used to be
I,
formality, right? So like I think they,
Yes.
they went through a major
ooh,
rebrand,
Hmm.
why'd
and
they
there
go
was
to?
this.
Yeah, wait. What? What? I know this name. What? Sorry. Keep. I'm just trying to Google this now because I knew formality.
Yes, Victor
Do you want to talk about
Maya's
it, Nathan?
language. Oh, sure. I think honestly, you're better equipped to talk about it because, okay, so formality is based on this very simple, minimal dependent type system, which allows this construct known as a self type. Now, these are not the same as self types within like Scala or such. Self types basically allow the type of a variable, a type of an expression to contain the expression itself. And apparently, with this very simple construct, you can actually do a lot of really powerful dependently typed things. And Victor Maya developed the language, which was once called formality, now it's called kind. His goal was to create a minimalistic, like proof assistant, which also runs blazingly fast. So, so self types allow you to develop what is, I believe, an what's the word, extensional type system, similar to I believe the like the concept of self types was first introduced by Aaron Stump in the Cedille language. Although I think Cedille has since moved away from it. I'm not super sure.
I don't think Sidil has ever had it. It's always been intersection
Well,
dependent intersection types,
I
but
see.
Yeah,
definitely
but
self
they
types
were
is from
kind
Iron
of
Stump. Yeah.
yeah, they were kind of like self types by being what is it, not extensional, extrinsic or whatever
Mhm.
under that
I think
interpretation. Anyway,
so. I find it really fun to simply follow Victor Ma's like Medium page and just track his progress through this because you find a lot of really interesting tidbits in there. Like, for example, he implements something within it known as Lamping's optimal lambda calculus evaluation, or something of the sort. And I have not gone through that in detail yet, but there is a very interesting post which he has, which where he says that he has discovered that for some reason on particular algorithms his new language seems to have negative complexity where you increase your input and it decreases the time in which it runs, and I have not understood it. I do
Damn.
plan on going back there, but it's
that's
absolutely
hilarious.
fascinating, and like it's certainly something I want to look at
That's
in more
now
detail.
that's something. Now that's
Yeah.
something. Wow. Huh.
That is
But
fun.
one thing
Mhm.
that I don't know. I've been lurking and looking in formality that apparently is now called kind. I'm not sure if they're the
Yes.
same. Are they?
They seem to be. At least the type system seems to have
So
remained
one
intact.
thing one thing that I don't quite understand is because if I remember correctly, the reason why Aaron moved away from self types is because he couldn't quite develop the method theory for it to be sound. So
Right. So I think that so a lot of papers nowadays, when they're trying to introduce dependent types into practical programming languages, they actually do forego soundness. If you look at the
yeah.
zombie
Yeah.
paper, there are there's this paper, I think it was System I Sub, which talks about integrating subtyping and dependent types. Like a lot of them do permit rules which allow for inconsistency.
Hmm.
The general idea is that sure, you can like screw things up in this language, you can prove things which may not be true, but it's not likely that you will do so, and we're still
So
providing a lot higher security guarantees than you would get otherwise. And I think kind also goes on that philosophy, although personally I don't really know how you would prove false in using self types, but it does. I mean, the concept of using your term within the type of the term is very suspect. Like,
Hmm. Yeah, that's odd. That's a very tricky relation between type and term.
though, you mentioned that Aaron Stump said that self types are. Did he fail to prove that they are sound, or did he prove that they are unsound?
yeah, if I remember correctly, again, I might be slightly mistake, but when I was actually more proactively looking into this, which was a couple of years ago by now, he actually proved that the way he was talking about it was inconsistent. So I think that the main idea is maybe there are ways to patch it up, but Aram himself decided to move directions and go to intersection types instead. Ah, yeah. Anyway, so my main point here is not about, like stumbling upon these errors. It's more of, I don't know, I feel like there is a lack of formalism in the sense of I'm not convinced anything works, like there is no intuition of why this calculus should work. That's my complaint. Or maybe I'm just, like, because I've thought about this a little bit, because like we're in academia, and like we have all this pressure to publish and to prove correctness and to be scientific precise, right, and make things from first principles. And I don't know, maybe we're just trying to, well, this maybe just trying to what's the word gatekeep the access for programming languages and interactive improvers. Maybe it's a possibility. Like
And like certainly when you say a language may not work, it means very different from someone in the industry who develops compilers saying the same thing.
Yeah.
Like
Yeah.
you're pointing at different objects.
Yeah.
Maybe I should invite Victor to my podcast. That'd be interesting.
Oh, that would be fascinating.
Actually, yeah, I'm curious how would that go. He's Brazilian as well. I'm actually talking to another Brazilian on Twitter that is working on this. That's why, I was asking if they were using self types and whatnot. I'm gonna make him more questions. Well, thank you so much for being here with me. I think we had an amazing conversation. We touched so many subjects. It was, I don't know, I felt like it was kind of light in the sense of we're just, going through a bunch of different projects and sharing our knowledge and discussing what we think about stuff. I hope the listener doesn't take our words as complete truth, because
please don't.
we are dumb as fucks. Is there any final thoughts, complaints, or words in general you guys would like to share?
Thanks for having me.
Yeah, I'd actually like to give another shout out for. I'd like to give a shout out to the Topos Institute and their workshops on polynomial functors. It's become like a really interesting and active research area for applied category theory, and that includes sort of the type theorists and them representing like data types and stuff like this, but also like also using these tools like representative like systems and their behaviors, like coalgebras and stuff like this. So they have a seminar going on. It's called Intercats. It's Seminar on Categorical Interaction, and there's going to be things like profunctor optics and lenses and stuff like this. But it's a larger community than just functional programmers and type theorists. It's other folks in applied category theory. So I think it's an interesting area to meld with folks outside our usual community, but on topics that we know.
But wait, so it's a series of workshops that happen constantly?
Oh, it's a seminar series on their site. I'll post a link. They also have a workshop on polynomial functors. There's an interesting intersection where you have folks from the mathematically structured programming group at the University of Strathclyde under Connor McBride. You also have like Bartosz Milewski, the functional programmer icon. And then you also have a lot of researchers from the hot community as well, like Steve Alliday and Emily Ryle will make appearances. But then folks outside of this community as well, like other people in applied category theory. It's just very interesting if you're looking for something that's not traditional CS stuff, but is on topics we know.
Yeah, big shout out to Topa's workshops. Awesome. Well, thank you so much, guys, for coming. I hope we can do more of these episodes in the future. I hope you guys had fun.
Until round 3.
Until round 3. Take care. Man, this episode was different than usual, but I hope you guys still enjoyed. But I want to know you guys' opinion. What are your favorite tools in Coq? What did you wish existed there, and why? Send us your thoughts in our website, typetheoryforall.com, or interact with us on Twitter @TT4all. And one more thing I'd like to share today is that I don't know if you guys saw this, but the Oregon Programming Languages Summer School has opened its applications. There, it gathers a bunch of really cool researchers in PL for a week or two to teach all the cool stuff happening in PL. And it doesn't really matter your expertise level because they usually cover subjects from the most introductory to the most novel in our field. It will happen from June 20th to July 2nd. If you think this is interesting, make sure to check their website and apply ASAP. You can find the link in our description. I think that's it for today, and I'll see you guys next time.